So good morning or good afternoon, depending on where you're calling from. Thank you for joining us for today's live session at Digital Africa. My name is Kenneth Mbe of Digital Africa, and today we'll be talking about identified active irrigated cropping, an opportunity to use the Digital Africa products to actually evaluate an irrigation scheme and how best to monitor this irrigation scheme, and as well introduce our new course that we developed with IMI, our partners, that addresses irrigation monitor of irrigation scheme. Welcome. So Digital Africa was set up a few years ago with the objective of addressing sustainable development for different, all the countries in Africa, looking at different sectors from agriculture, water, land, urban and coastal. And we work with all sectors and partners in Africa. Access to the platform so far, you've been able to see access to the Digital Africa map and sandbox, and even our free online modules that are open for all, leaving no one behind. For today's topic, we're looking at areas where we have active irrigation, and the question is how best you can monitor an irrigation scheme. And using the Digital Africa workflow, we can actually access surface temperature from the Landsat data, and this will be an indicator of whether crops are stressed or actually they have access to the actual water resource that they require, and how best to monitor the areas. So the workflow is more of our data sets, which are analysis rate data Landsat 8, and also coupled with additional data from ARA5, looking at air temperature and how we can model these to show active irrigated areas. The workflow is step by step, where we load this land surface temperature from Landsat 8 and also load the ARA5 temperature data for the same area of interest and calculate the change over time. As you introduced the definition of this particular indicator that we are looking at, the change in temperature from the crop canopy as well as air temperature. And the workflow starts with the loading of the packages that we require, which are step by step, and the notebooks actually pre-run for you, and we can run it for any area of interest. The second part is actually to identify the area of interest, and for this case, we provided an example in Sudan, quite a dry area which has been under irrigation for some time. And based on this, just as an example, we'll be able even to share another example of a certain area. And also, as our champions, different parts of the world, you can be able to use the notebook for different areas. Once you selected the area of interest, which can be through the coordinates or actually sharing your shapefile or geosum file, you can be able to run the analysis. So this part of the example south of Khartoum, and more closely specific, is that you have to know the area of interest, and this is an area which has been under irrigation for some time, and over time there has been some data collected that you can actually use and actually see how best to get temperature. So it's quite an area of quite dry land, and with the irrigation, it's possible to grow some crops based on this information. The other step is to load the surface temperature, as you can see, for this area of interest, of which we have data for the whole continent. And for this area, you can look at the timestamp of the area and the number of Landsat returned, which will give us the land surface temperature. After you get the land surface temperature, it's actually convert into Celsius, because the other one was in Kelvin data, as you know, and then be able to resample it for the region. As you can see, the region is quite hot area, areas of ranging over 40 degrees, especially in summer all long, and they quite require irrigation for a to monitor crops, or even to actually grow actual deciduous crops or fruits, etc., etc. Then this other step is to load the ARA5 air temperature data, which through this will have data at 2 meters for this area of interest. And thanks to this better collaboration, Africa, we're able to pull in data from external partners with all objective of supporting such an algorithm and initiative of supporting food security in Africa. The active irrigation coping, as you can see, now we have a we have the cells of the areas at 2 meters, and these are very key to map our area of interest, and we're able to model the temperature of the area and actually now get actual more information. So we've loaded the land surface temperature Landsat 8 and the ARA 5, then you've collected the change in temperature to actually get the temperature areas and actually differentiate these through a cluster analysis of irrigated and dryland cropping. As you can see, our area of interest is quite a hot area and a dry area. So calculating the change of the temperature, we'll get the difference between the land temperature and the air temperature from ARI5 based on this workflow methodology. And this gives us a simple result as shown in the next page, where now we're able to calculate the areas we've seen. And as you remember, it was quite a hot areas with temperatures even over 45 degrees for a year. It's quite a dryland area, so here our objective is to differentiate between areas which are irrigated and as well as dryland cropping as areas such we can grow some dates or other crops. So after doing that, we upload the surface temperature. It's actually calculate the vegetation index, normalized differential vegetation index based on the Landsat data, which is very nice as we have it in analysis ready data format. This is collection 2 based on the good partnership with the USGS and Amazon Web Services who are powering the Digital Africa platform. As we can see, the result is that we have the result of the land surface temperature as well as the vegetation index, and you can see most of these parts on the west northeast was quite very dry, and this was indicated also in the other chart that you could see high temperatures were recorded this side, very dry areas, but we have some vegetation around where we had the small rivers and valleys indicating some kind of dryland cropping and also advising the people around where to actually do irrigation, because these are areas which have no access to moisture based that the area is actually dry and the crops are stressed. With the Digital Africa work, collaboration of developing the cropland mask with partners across the continent, it is a very useful service that can guide us to bring out areas of probability of cropping, very key for the continent. They're very good insights. And as you can see, trying to mask areas where it's probable to get cropping, areas which we had which were green, which could also be vegetation, but now more specifically, could they be cropland areas? Then when you compare these two parameters, the change in vegetation and the change in temperature from the surface temperature and the air temperature, we're able to reclassify and get at least an idea of predicting the cropland areas in 2 dimensions. And going further, we come up with a 2-dimension histogram, which compares the vegetation index and temperature and giving us areas of likelihood of irrigated cropping. So based on this, we can actually get for the area of interest, areas which were probably irrigated and others were dryland cropping. And you can see based on these indicators, which is key, especially if you have some ground data of the region. So applying further clusters to the spatial data and using the geomedian, which we have now from annual to semi-annual, every 6 months, we can be able to get more refinement on how the vegetation has changed over time. And based on that, we're able to plot the results from what we get from the true color geomedian of the areas. And you can see areas which were suspected to be irrigated cropland, but also area that is also suspected to be some cropland areas. And this is captured using the cropland extent from Digital Africa side. You can see those areas, and we can now have those other areas which were cropping regions but now classified under active irrigation. So areas which are quite stressed and have been irrigation. And this is based on this methodology by the scientist Jackson and team in their crop water stress index determination. This so far has been a very good example, and just to show you a demo on the sandbox. On your sandbox, you'll go to the irrigated cropping in the real world example. And once you run the notebook, you're able to change the area of interest For example, our area has been in Sudan, south of Khartoum, an area which has been, there has been some irrigation initiatives before, and this is just around a riverine, a riverine area, and loading the surface temperature Landsat 8 and converting that information now from Celsius, Kelvin to Celsius data. Temperature, as you mentioned, areas which were above 40 degrees temperature, quite semi-arid areas, and the surface temperature is loaded, and you're able to change the various parameters, and comparing land surface and vegetation. You can pick out some of the areas, putting in the cropland extent. We can be able to see the area, and finally be able to identify the area for cluster classification and make a plot so as to identify the irrigated areas, and finally applying this spatial data, and finally plotting the results. And this is ultimately decided by you because you understand the ground information or the ground data of your area of interest. Based on this example, I wish also to share another example for a region called Kalumsa in Ethiopia. This is based on an irrigation scheme area where there has been some active work by Ethiopian Institute of Agricultural Research, and it's quite a big area where they grow teeth, and they run irrigation scheme. And you can see also the temperature is quite hot on the northwest. It's a semi-dry area, and also comparing the surface temperature and the vegetation index, can see some areas which were dry, and running a crop mask, and finally doing your cluster for classification to actually identify some irrigated areas, which we'll see in the southwest of this area, and finally plotting the results of your analysis work. And you can see more irrigated areas identified on the northwest for this particular example. And also going further is that Digital Africa, in collaboration with IMI, co-developed a course on how to access the IMI products of digital innovations for water security. And now we developed this course in English, where we have 4 modules: an introduction, and the second section on evapotranspiration. And also we have a section on rainfall estimation, and the other session is on soil moisture in an irrigation scheme, which there was a specific area given by one of the researchers, and even based on this publication, there was some ground data collected, and here we use Sentinel-2 imagery, and we're using a shapefile of the area and actually mapping the soil moisture and actually analyzing areas which are under crops water stress. And this is just a short demo of the same, and this course is available on our platform, which will be able to show you that you can sign up and go through the module. Initially, now we have the module in English, and we'll translate it to French, possibly with more examples from our colleagues at IMI West Africa. We have areas of interest, but for now, this is just an area of work that we can just use as a model based on the work done by previous researchers in providing the notebooks, as well as the steps to get information on how to monitor an irrigation scheme, which is similar to the other notebook that I showed you before. But now we will see more specifically, we can go at different time steps of in 1 year, as well as get the normalized difference moisture index as well, and seeing areas which are quite stressed, and going further to identify areas plotting the soil moisture, and also looking at the mean index, and finally getting the coefficient, showing you areas of stress which are in red for this irrigation scheme, and finally having a plot of those statistics, which when you analyze in other programs like R statistics can be able to show you how best to monitor irrigation scheme, and also involving all the stakeholders who are very key in management of the irrigation scheme, as well as promoting food security in Africa, which is very key, and that is one of the ambitions of the missions of the program, to empower all decision makers So the courses we have are in English and French, which most of you have completed, and we are very grateful for your support this far, and even the comments that you provided with us to improve the courses and bring more courses. And we have these live sessions in English and French, and next week, the next session will be in French with my colleague Joseph. That will be in the other week. And we keep acknowledging our partners who's made this program a success, especially the Australian government and Helmsley Trust and other partners, even you stakeholders who are here to promote us and support us in all ways. I wish to stop here and thank you so much for connecting with us. And is even the link to a survey that you can connect and get more feedback and provide us with more inputs that you'd like to see in the live session as well as the program. And also today we'll do